So with relations, all you're doing is you're doing a set of ordered pairs, but this is helpful to know about relations. There are no constraints. When we talked about a long time ago functions, what were the constraints on a function? Every x has what? One y. Do we have that constraint on a relation? No. So it's any set of ordered pairs. All right. A couple things, though, that I found that I think are nice to know are the notation. Would you write in x comma y is a subset of R? Now, R is not the real numbers this time. This is relation, element of this relation, whatever the relation is. And then they had R was a subset or equal to A cross B. That was another one. Any pairs. But the shortcut is the one I think is the most interesting. X relation Y. That you're going to see quite a bit. And when we see symmetric reflexive transitive, this XRY notation will be super helpful. And then the other one is a relation of A to B. So those are some notations that they came up with. And you can read about that here. But so, you know, you have this relation, but look at some of these. These are kind of interesting. 1, 3, 2, 4, 3, 1, 3, 4 is a relation of n, which are the natural numbers, to z plus. This should be the word 2, not or. It's a misprint. How about this one? 1, comma 2.5, 2, comma 3.7. Those are the natural numbers, or the positive integers, to what? What's 2.5, 3.7? Those are rational numbers, so n to q. This one is kind of interesting. It's a relation of x and y, and that's to this 2d is going to the 1d, 1, and then this one is the relation, in R, and this is from 1 to 2. We'll talk about those. All right, so reflexive, there's 3 equivalence relations that are going to be hammered into your math psyche in the next couple days. We'll just introduce them today. The reflexive is your ARA. Okay? Start with A, it reflects to A. So if you have members 1, 2, 3, and 4, the reflexive relation would be 1, 1, 2, 2, 3, 3, 4, 4. And they have some examples here. I do want to look at B. The relationship in children in a family is the brother of. Okay, so is that reflexive? So is another brother, let's say a boy is, and another boy is, from the first boy's point of view, they're a brother. Okay, so that would be reflexive. But if they were a girl, could they have a brother? Yeah. So it doesn't quite work out reflexive. Not every brother is the same gender. Relationship is, and then some of these, x, y, if x is less than or equal to y, that would be reflexive because you could have x is less than or equal to x. And D was not reflexive. 1, 1, 1, 2, 3, 2, those aren't reflexive. Then symmetric. Now, what we're saying here is that members A, R, B are mapped to B, R, A. Okay? And those would be symmetric. So if you have a 1, 2, you better have a 2, 1. If you have a 4, 2, you better have a 2, 4. A 3, 3 is reflexive, but it's also symmetric. So the relationship of a set of people is the sibling. Well, let's just look at this first one. This one is definitely symmetric. The relation of a set of people is the sibling of siblings. Brothers have siblings of sisters. Sisters have siblings of brothers. So yes, that is symmetric too. Is the brother of, is that symmetric? Is the brother of? Is everybody the brother of going to be symmetric being a brother? Not if you're a sister. You can have a brother, but the brother won't have a brother then. So this would be no. And then x, y, we did the x less than y, x equal to y. The x equal to y works, the x less than y does not work. Okay, so symmetric and anti-symmetric. So we describe it as non-symmetric or not symmetric. The term anti-symmetric is reserved for a special case, so don't use that. Sounds like a bad word too. Use non-symmetric. Okay, and then last one, transitive, and that's the one you're familiar with. If A, R, C, when A maps to B and B maps to C, then A can map to C. So there's your transitive. So the relation 1, 2, 3, 4, 1, 1, 1, 2, 2, 3, 1, 3. Okay, that's transitive because you're getting back to the 1, 2, 1, 1, 1, 2. See how those in between there is going to work. You have the 1, 1, 1, 3. So that one is transitive as well. So this is true. Relationship of buildings is older than. That would be transitive because you have one building older than another building older than another. First one's older than the third. That would work. Is the father of? Will that work? If fathers B and B fathers C, then A is the grandfather. It's not the father. So that's why that one would be a no. Real careful with things like this nowadays because there's so many complexities to family relationships which are all interesting. Relation is transitive for x less than y. Yeah. If 2 is less than 3 and 3 is less than 8, okay, is 2 less than or equal to 8? Yep, that works. How about the equal? If 2 equals 2 and 3 equals 3, those will also be transitive. So the only one here that wasn't was the whole father thing. That was good. So here's a whole bunch. The domain are the x or the first ones, and range are the second. Nothing new there. So you're going to be able to answer these. Let's do it. Let's do this one here. What's the set of domains here for number 1A? What will that be? Real quick. 0, 1, and 2. Okay. The range will be 5. 3 and 2, easy. Okay. Now, for this is where it gets interesting. What values of x are in the domain for x squared plus y squared equal 9, comma x element of z? Well, apparently x is an element of what? Z, right? So what's the range going to be? Let's get tricky in a hurry. What do you think? If x is an element of z, what values of x are going to work? There's only a few. Yeah. 0 is 1. What else? I like it. 3 will work. How about -3? How about 2? How about 2? Will that work? Yes, it will. -2 and 2 will work. 1 will work. -1 will work. And then will y, I guess we could put these in a set notation. What are the values of y that are going to work? I think you'll have 0. You'll have square root of 5. You'll have square root of 8 and 3. Because anything else won't work. Am I missing anything? Yeah, plus or minus 3. Yeah. Good. And then these, you're putting in some factors here. It says, suppose R is a relation from A to B, right? R is a set of ordered pairs. X, R, Y, if X is a factor of Y. So you're going to have this X, R, Y, and that's going to be, give me one pair that'll work. Mm-hmm. 2, 6. Another one. 2, 8. Another one. Help me out. Not hard. 2, 6, 2, 8, 3 what? 3, 6, 4, 8, 5. Yes. Yes. Good. Okay, so there's your ordered pairs. And they had 5, 5 listed last as well. All right, so you can do those, no problem. And then with these, determine whether each of these relations is symmetric, reflexive, and transitive. And we talked about those examples, and maybe it might help just to do the first one here. X relating Y. Y is the brother of X. Is that reflexive? Well, we said no if X is a sister, right? Is it symmetric? Is X, R, Y equal to Y, R, X? No, if X is what? Sister. And then transitive. If you had X is a brother of Y and Y is a brother of X, if X is a brother to Y and Y is a brother to X, would this be transitive? Would the first one be a brother to the last one? X is a brother to Y and Y is a brother to Z. Brother. Brother. Yeah, they would, wouldn't they? So yes, this is going to be transitive. X, R, Y, and Y, R, Z, then X, R, Z. Yes. So this would be no, no, and yes. And they didn't use very much symbolism here, but they did use this X, R, Y is not equal to this. They said that X, R, X does not exist for that. So you just try those. Those get a little tricky.